In the realm of medical science, few challenges are as daunting as Alzheimer's disease, a relentless adversary that slowly erodes memories and steals away cherished moments. But what if there was hope on the horizon? What if, through the power of relentless research and innovative technology, scientists have finally found a way to reverse the debilitating effects of Alzheimer's? Welcome to our channel, where we delve into the latest advancements in science and technology. Today, we bring you a groundbreaking discovery that promises to change the landscape of Alzheimer's treatment forever. Synapses, the crucial connections between neurons in the brain, are often damaged in Alzheimer's patients, leading to memory impairment and cognitive decline. But what if these connections could be repaired? Join us as we explore this remarkable journey of scientific discovery, offering hope to millions affected by Alzheimer's worldwide. Don't forget to subscribe and hit the notification bell to stay updated on this incredible breakthrough. Together, let's unravel the mysteries of the human brain and pave the way for a brighter, Alzheimer's-free future. A groundbreaking study highlights a revolutionary approach to treating Alzheimer's disease that centers on memory restoration by mending damaged synapses and making use of the vital function of the KIBRA protein. This method appears to be promising in restoring memory loss without going straight after the buildup of harmful proteins. Current Alzheimer's treatments are incredibly ineffective in helping patients restore their memories, even though recently approved medications appear to have some potential for slowing the disease's destructive effects. According to Buck Assistant Professor Tara Tracy, Ph.D., the senior author of a study that suggests a different approach for correcting the memory issues that accompany Alzheimer's disease and related dementias, more therapy options focused on memory restoration are required. Investigating novel treatment options for Alzheimer's. The team decided to take a different approach because the majority of current research on possible Alzheimer's therapy approaches concentrates on lowering the toxic proteins, like tau and amyloid beta, that build up in the brain as the illness worsens. We are attempting to reverse the damage caused by Alzheimer's disease to restore memory, rather than reducing toxic proteins in the brain, Tracy stated. The results can be found in the Journal of Clinical Investigations February 1 issue. The protein known as KIBRA, so named because it is present in both the kidney and the brain, is the key to the operation. It is mostly found in synapses, the connections between neurons in the brain that enable the formation and retrieval of memories. According to research, KIBRA is necessary for synapses to establish memories, and Tracy's team has discovered that Alzheimer's disease brains have low levels of KIBRA. KIBRA's function in memory restoration. Co-first author of the study and Buck staff scientist Grant Kawa, Ph.D., said, "We wondered how the lower levels of KIBRA affected signaling at the synapse, and whether understanding that mechanism could yield some insight into how to repair the synapses damaged during the course of Alzheimer's disease. We have discovered a mechanism that may be used to restore synaptic function, and we are currently working to create a treatment plan based on this research." The first thing the researchers did was measure the amount of KIBRA in human cerebrospinal fluid. They discovered that the degree of dementia was correlated with higher levels of KIBRA in the cerebrospinal fluid but lower levels in the brain. In the cerebral fluid, Tracy added, "We also discovered this amazing correlation between increased tau levels and increased KIBRA levels. The strength of the relationship was quite unexpected and suggests that tau has an impact on KIBRA in the brain." In order to determine whether KIBRA may be utilized as a biomarker of synaptic malfunction and cognitive decline for the purposes of diagnosis, treatment planning, and monitoring the course of the disease and its response to therapy, the team is delving deeper into this phenomenon. Positive findings from the KIBRA study. The researchers produced a functionally truncated form of the KIBRA protein in order to investigate the effects of KIBRA on synapses. It was discovered that this protein can cure the memory impairment linked to this type of dementia in lab mice with a state that resembles human Alzheimer's disease. They discovered that KIBRA protects processes that increase synaptic resilience. Christine Pareja Navarro, a co-first author of the study, noted, interestingly, KIBRA restored synaptic function and memory in mice, despite not fixing the problem of toxic tau protein accumulation. Despite the fact that the harmful protein that initially caused the damage has not been eliminated, our research raises the prospect that KIBRA may be utilized as a treatment to enhance memory after memory loss has begun. In addition to current and upcoming treatments, KIBRA therapy for synaptic repair may prove to be beneficial. According to Tracy, repairing synapses and improving their function is another critical factor that could help, but reducing toxic proteins is obviously important. I believe that this will have the greatest effect down the road. Thank you for joining us on this remarkable journey through the realms of scientific discovery. We hope you found inspiration and hope in the groundbreaking research we've explored today. As we venture into the future, let us carry the torch of optimism and determination. Together, we can continue to unlock the mysteries of the human brain and pave the way for a world where Alzheimer's is but a distant memory. Don't forget to subscribe to our channel and hit the notification bell to stay updated on the latest breakthroughs in science and technology. Thank you for watching, and until next time, stay curious.